Hey everyone, and welcome to today's Explainer. Look, if you're building, managing, or honestly even just interacting with modern software, you're constantly relying on cloud computing. Every single time you open an app on your phone, check a live weather feed, or securely transfer funds between bank accounts, there's this massive network of applications talking to each other right behind the scenes. And at the very heart of that entire ecosystem, well, there are two heavyweights making all this communication possible: SOAP and REST. Mastering these two architectures is essentially mastering the backbone of cloud computing itself. So today, we're going to break down both of these web services, compare them head-to-head, dive deep into their structural differences, and figure out exactly when and why you should be using them in your own development environments. Here's a quick look at our roadmap for the session. We'll kick things off with an intro to web services, move right into understanding SOAP architecture, and then break down the RESTful approach. After that, we're going head-to-head on protocols and structure, unpacking the stateless difference and security, and finally, wrapping up with the final verdict and use cases.
Okay, let's dive into this. Section 1, Intro to Web Services.
Before we put SOAP and REST in the ring together, we need to establish exactly what ground we're standing on. Like, what is the fundamental job of a web service anyway? At its absolute core, whether we're talking about SOAP or REST, a web service exists simply to connect a sender and a receiver. It's an API, an application programming interface that allows a client to request data and a server to respond back with that data over a network. Imagine two totally different pieces of software, written in completely different programming languages, living on servers halfway across the world from each other. Web services act as these incredible universal translators. They allow these totally distinct systems to exchange messages seamlessly, passing variables and datasets back and forth without needing to know a single thing about how the other system is internally coded.
Moving right along, Section 2, Understanding SOAP Architecture.
Let's start with our first heavyweight: the strict, highly standardized world of Simple Object Access Protocol. You probably know it as SOAP. Now, SOAP is a protocol that exclusively relies on XML, extensible markup language. You can't use JSON, you can't use plain text, it absolutely has to be XML. And XML is, well, incredibly rigorous. Developers literally have to manually create custom tags for everything, and every single tag you open must be explicitly closed. It follows the super strict parent-child relationship in its formatting. You're basically building a highly structured tree of data every single time a message is sent. And because of all that heavy markup, SOAP payloads are famously large. The parsing overhead required for the server to read through all those opening and closing tags, it consumes some pretty significant bandwidth and processing power.
And that strictness? It applies directly to the message structure itself. Every single SOAP message is wrapped up in what's called an envelope, and inside that envelope, it has to follow an exact anatomy. Step 1 is the message header. This contains really specific routing directives and security credentials. Then, step 2 is the actual message body, which holds the data payload you're actually trying to transmit. This structure is totally fixed. You will always have that header, and it's always going to be followed by the body. There's no bypassing the standard. It's unyielding. But, as you'll see when we talk about enterprise systems later, that rigid predictability has a massive purpose when it comes to transactional reliability.
All right, let's shift to Section 3, the RESTful approach.
Time to shift gears entirely. If SOAP is the strict, formal corporate letter, REST is the dynamic, highly efficient text message. Representational state transfer completely breaks away from the mandatory XML of SOAP. Instead, it overwhelmingly favors JSON, JavaScript Object Notation. Instead of all those heavy nested opening and closing tags we just talked about, JSON represents data intuitively using really simple key-value pairs. You have a key, like city, and a corresponding value, like Paris, or unit and C for Celsius. It is remarkably clean and just incredibly lightweight compared to XML. Because it strips away all that heavy syntax, your payload size drops dramatically, which obviously gives you much faster transmission speeds. Plus, JSON maps directly to native data structures in languages like Python and JavaScript, so it's instantly readable by both humans and machines.
So how does this actually look in a request? Well, REST uses standard HTTP methods, specifically GET, POST, PUT, and DELETE, to perform its actions. Engineers usually map these straight to standard CRUD operations: create, read, update, and delete. When a client wants data, it just points to a specific endpoint or a resource URL. For example, your client asks the server for the URL ending in /weather using a GET request. The server processes that and instantly fires back a lightweight JSON response representing the current state of that resource, saying, the high is 23 and the low is 16. No massive envelopes, no complex headers required, just a direct request to a specific URL and a direct response.
Now, what's really interesting about this next slide is how they stack up. Section 4, Head-to-Head, Protocols and Structure.
Okay, we've seen both architectures on their own. Let's put them in the ring together for a rapid-fire showdown. On one side, we have SOAP's strict structure. Like we established, it demands a mandatory header and body for every single communication. It is uncompromising. That means every client and server interacting with a SOAP API must strictly adhere to a shared, predefined contract. On the flip side, REST offers incredibly flexible methods. It relies purely on standard HTTP verbs and specific URL endpoints. REST doesn't force a heavy envelope onto your data. If you literally just need to fetch a quick user profile, REST lets you do that cleanly and efficiently without any of that bloated overhead.
Now, this structural difference has a huge impact on the day-to-day developer experience. Because SOAP has such heavy standardization, strict schema rules, and requires complex XML parsing, it generally demands a much higher skill level to implement, debug, and troubleshoot. REST, on the other hand, because of its sheer simplicity, its straightforward endpoint architecture, and really readable JSON formatting, only needs a low to medium skill level. The onboarding time is night and day. A junior developer can usually start making functional REST API calls on their very first day, whereas navigating a complex SOAP enterprise service, that can take weeks of studying strict architectural contracts.
But here is exactly where SOAP fights back. SOAP is completely independent of the underlying transport layer. Sure, it can use standard HTTP, but it can also use TCP, UDP, or even SMTP. Actually, think about that for a second. You can send secure SOAP messages asynchronously over email protocols. That makes it insanely versatile for legacy systems or highly restrictive network environments where standard web traffic might just be completely blocked. REST, however, is heavily reliant on HTTP. It literally lives and breathes on the standard web protocol. If HTTP isn't an option for your system, REST completely falls apart.
Moving to Section 5, the stateless difference and security.
If you only remember one takeaway from this entire explainer, make absolutely sure it is this: REST is stateless. I really want to slow down and emphasize this because it is a very important line. It's the secret engine behind modern web architecture. Statelessness means the server does not store any information about the client's session between requests. Every single request from the client has to contain all the necessary info: authentication tokens, parameters, the whole shebang, for the server to process it independently. And this is exactly what gives REST its massive scalability. Because the server doesn't waste memory remembering thousands of user sessions, it can handle massive traffic spikes. Plus, if a server crashes, a load balancer can just instantly route the next request to a completely different server. And since that new server doesn't need previous session history, the user experiences zero interruption. It's an absolute game changer for horizontal cloud scaling.
Let's look at this ultimate cheat sheet for data formats and security. Notice the flexibility with REST. It handles XML, JSON, or even raw CSV files depending on what you ask for, while SOAP is locked firmly into XML. But the security column is where things get really distinct. SOAP provides robust, standard-based enterprise security right out of the box, known as WS security. This gives you advanced features like non-repudiation and message-level encryption, so the payload stays secure even if it's hopping through multiple intermediary servers. REST is much more lightweight, so it delegates security to the underlying transport layer. It relies on modern HTTP security like SSL and TLS, HTTP basic auth, and standard token systems like OAuth. Both are highly effective, but the key difference is REST secures the connection, whereas SOAP secures the message itself.
Which brings us to Section 6, Final Verdict and Use Cases. We've looked at the structures, the protocols, the security. So what's the final resolution? When do you actually use which service in the real world? It all comes down to your core requirements. SOAP is an absolute powerhouse of reliability. Thanks to its strict standardization, WS security, and transport independence, it is the go-to for complex, enterprise-level applications, both web and non-web. Think massive banking systems, legacy telecom, or financial transactions where you absolutely need guaranteed ACID compliance. REST, on the other hand, overwhelmingly rules the modern web app domain. Its stateless scalability, high-speed JSON efficiency, and low barrier to entry make it the undisputed champion for mobile apps, microservices architectures, and public-facing APIs.
And that brings us to the end of our breakdown. You've now got a clear, structural framework to really understand both SOAP and RESTful web services. You know the exact rules they play by, the data formats they use, the mechanics of statelessness, and exactly where they thrive in the real world. So, looking at your own architecture, factoring in the skill level of your team, weighing rapid scalability against strict transactional reliability, which web service architecture fits your next big project? Take these insights, start building your next great application, and I'll see you in the next explainer.